talk to you about a part of my dissertation research that I've been doing in my lab in the last few years. In our lab, we are interested in understanding what leads to the development of anxiety disorders such as depression, social anxiety disorder, or trauma such as post-traumatic stress disorder. Now, what is the one common characteristic feature of all these disorders? It's excess fear. Now, fear, while it can help us escape dangerous situations when present in excess, it's not so good because that can then lead to the development of anxiety disorders. One common example. Let's say you've been taking this elevator in your building to get to your home in the last 15 years. However, one evening you get on this elevator, the lights go out and it gets stuck. The experience of being stuck in that elevator is so fearful that it now prevents you from getting into this elevator to get into your own home, or for that matter of getting into any other elevator even though you know that these are all safe. This excess fear is bad because now it's preventing you from going about your normal routines in your regular life. Now, I don't need to stress on how prevalent anxiety disorders are in the entire world. Just in the United States alone, 1 out of every 5 individuals have a likelihood of being diagnosed with an anxiety disorder. Not only that, a person who's been diagnosed with one type of anxiety disorder has a 27% chance of being diagnosed with either another type of anxiety disorder or another disorder such as substance abuse, drugs, alcohol, etc. So it's important that we identify what are these common components of these different disorders. Not only that, but to understand what is going on in these common components that are regulating fear processes. So for my experiment, I have decided to look into the nucleus accumbens. Reason being that it's been implicated in both substance abuse and anxiety disorders, which are comorbid. And within the nucleus accumbens, I'm going to look into glutamate signaling. Now, glutamate, it's a neurotransmitter, and a neurotransmitter is how different brain regions or even neurons within a particular brain region communicate with each other. Now imagine that there's a completely safe environment, nothing can go wrong. In that, an active glutamate signaling in the nucleus accumbens shell results in a very happy mouse, and mouse because we study mice in our experiments. And that's been shown by these white dots over here. So this low levels means that there's a low level of fear. But when you block these glutamate activity within the nucleus accumbens shell, it results in a fearful mice as seen by the black dots over here. Alright, so they show a higher level of fear, which is telling us that glutamate signaling within the nucleus accumbens is required to suppress fear because otherwise it results in excess fear, and that's not so good.